Oh, GrrCON. How's it going? You guys having a good time? Yeah! Phenomenal keynote this morning. I'm so glad I'm on a watch list now. Thank you for coming to this talk. This is Punch Counter Punch. It's actually part 2, right? So the original Punch Counter Punch I did at GrrCON like 2 or 3 years ago. It was client-side .NET code. You know, Alice wants to talk to Bob, and we're going to break it. And you caught that talk.
Yeah, I caught the talk. I think I was at a WASP meeting a couple days later. After I watched it, I pretty much went and I made a tinfoil hat, sat in the corner for a little while, and it was pretty scary.
Scaring developers since 2012. So this one we're going to be looking at web apps. Got some disclaimers? Oh, disclaimers. Disclaimers.
So first disclaimer is there is no beard length guarantees. Although I've always had one. Have you always had one?
I was born with a beard. Yeah. I don't know if you guys can see it, but beards will always be attached to our sexy faces. We cannot guarantee length, but we can. Wait a minute. No, go ahead. Next one. That almost was bad.
I'm of Middle Eastern descent, so you guys are probably all going to be on a watch list after this.
Between Chris Roberts and you.
With this crowd, they're probably already on one. The third one is we are not representing our employers. This is something that I do kind of on the side. And
yeah, I do it full time. Not representing our employers, but I'm with CBI. We've got a booth, so we're one of the sponsors. So come by and visit, but this is definitely outside of that. Not even close. Try again, sir.
Fourth one is opinions are our own. The advice is provided with no warranty. Therefore, if you go back and implement an algorithm that we made and you get screwed, don't come crying to us on Twitter and or any other social networks that we may or may not.
And if you do come crying to us on Twitter, we will use it in a future GrrCON talk.
Please follow me on Twitter.
All right, so I am Wolf Goerlich, big advocate for the Michigan community. I love you guys. This is a phenomenal community. We do a lot of cool stuff. Involved with GrrCON, involved with Converge, the B-Sides Conference, MySec, OWASP. Fantastic group of people. I'm so glad to be here. I am classically trained as a developer, which is a lot like being classically trained as a pianist, which means no one pays me. I was originally going to be a developer, and then I led some dev teams for a while, and I had a lot of fun with it. I still love code, but I don't get to write it very often. I'm a strategist at CBI, where I work with very senior security leaders to define strategies, solve seemingly intractable problems, and then work with very junior folks with my CBI Academy, my team's here, which is phenomenal, bringing in the next generation hackers to solve these problems. And I talk too much, I tweet too much, I blog too much, I do videos, blah, 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 blah. Mo.
A little bit about myself. I am a software architect. What that means is I'm basically a glorified web developer. I pretty much create pretty diagrams so business people can understand what the tech people are talking about. And most of the time that doesn't actually work, so I usually talk with business people and tell them that that's what to do. I'm also a craftsman. I've been a developer all my life. My first job was as a developer when I was 14 years old. I was making pre-calc software. I'm pretty sure that a lot of students failed pre-calc that year because of me.
At 14?
At 14. Well, I never took pre-calc, so I don't know how to build software.
Business analyst. Go ahead.
I'm a wannabe security guy. Security is my passion, software security, application security. I'm very interested in cryptography, so I study that a lot on my spare time. The first time I really got into application security, I was building websites for a company that will remain nameless, and one of the clients basically showed me a SQL injection attack against my application. I'm also a husband and a father, and that means that against all odds, I have managed to stay married and procreate, which is amazing.
Give this man a round of applause. All right, so here's the setup. It's the nerdy pig and the big bad wolf. I will give you one guess who the wolf is. We are going to go, hey, here's how attack would happen, right? This is like 101 application pen testing stuff for some of you guys. For some of you other people, you may be like, oh, that's how they do it. Yes, that's how they do it. Then we'll talk about tinfoil, and then we'll turn it over to you.
Basically, what I'll do is I'll go through what a developer or the development team should do to mitigate against those particular types of attack within the code. And we'll show a lot of code samples and examples of how a development team will do that. The one thing I will say is all the code examples are in C#, but all the principles can be applied in pretty much any language or any framework that your dev teams use.
With that, let's break some apps. So, of course, the very first thing as the big bad wolf I'm going to do is I'm going to look at your website. I'm going to look deep into your soul. No, Google dorking, right? I love Google dorking. You would be amazed at the amount of stuff from Google dorking that we can get. What are keywords or passwords? What are business processes you guys are following? What's on the top of your mind? Who's the executives? Who am I going to fish? What are the names of the little pigs? I'm going to start there. I'm going to hit up FOCA. I'm going to hit up WebGout. And of course, we're going to do some Dirtbuster. Anyone in Kirsten's talk? Yay, Kirsten! She covered Dirtbuster, and I love it. Okay, Dirtbuster will scan your server for a whole bunch of different folders and files, right? So like WP admin, PHP admin, all those types of things. Dirtbuster has a very unique user agent. It is obfuscated as Dirtbuster. A lot of people know this, right? So, okay, who's monitoring for that user agent in their SIM? Anyone? One guy, thank you. Yes. Be that guy, people. Be that guy. A lot of people go, attackers, they can change their user agents. They don't. Do you know why? Because it's only that guy. So I'm going to get some great information on how to attack your site. And from there, now that I've got an idea of what the website is, what are some keywords that I can use, what are some pages on this thing, I got an idea of what you may be running. I'm going to run burp on it. I'm going to run zap on it, W3AF, WScarab. I'm going to basically fingerprint the heck out of it and look for common vulnerabilities and common weaknesses, ways that I can get in. W3AF, right? Crawl the site. And from that, I'm going to say, okay, what type of site is this? I know it's a WordPress site. All right. I know it's got some SQL on the back end. Okay. Again, automated tools, run through SQL map, and pull out every single page that has SQL injection on it. And by the way, the big bad wolf, right, is a great metaphor. Me against you. Mano y mano. Man against man. Cyber attacks. No, but the reality is these types of scans go on like crazy because, cybercrime is now an industry. They've got developers who are running DevOps teams and they're SQL scanning everything. And again, things we should watch for. Same thing with WP scan. Oh, I have for the longest time I ran my blog on a C# thing, and I had WP admin page on it. I loved it. I loved watching the people run WP scan on me. It was great. Keep coming. Come at me, bro. So we run these things. We get some great insight. And then we can go ahead and get into the next step. Now, meanwhile, the little pigs got some opportunity to catch me, got some opportunity to respond.
So, when you talk about recon, in this phase of an attack, most software developers are not looking for things that are happening. Typically, you're responding, you're not kind of being proactive. So how do we become proactive as software developers? The first thing is you have to understand that security is a cross-cutting concern. And what that means is security is kind of on the level of logging. You should be looking for places where your application can fail throughout your code, not just on the periphery. Like, I love web application firewalls, but it's on the periphery. It does nothing to protect the app itself or specific attacks against that particular app. So what you want to do is you want to set up detection points within the application, and then you want to detect abnormal conditions. Abnormal conditions are things that would flag you that something is wrong. Like, if you look at this picture, first thing you think when you're driving and you see something like this is, I have to stop.
And do a video. Stop and do a video. Go ahead.
But you see this and you say, okay, I got to stop. You don't necessarily know what's going on ahead of you. You don't know if there's a stoplight. You have no idea if it's an accident. The only thing that you know is there was an abnormal condition. My normal condition is I'll be driving, and now I should be stopping. So what are some abnormal conditions against a web application? High number of 500 errors. High number of 404 errors. If you can trap 403 errors on the application level, same deal.
So SQL injection, I'm running SQL map against you. That's creating a whole bunch of 500 errors.
That would create a ton of 500 errors, and Durbuster would create a whole ton of 404 errors. So those are things that your application developer should be logging and then making a decision against. So the other thing is attack attempts against known concerns. These are things in your threat model. SQL injection is one of them. If your developers know that there's a particular area of their code where they're calling the database, they should be looking for, in that area of the code, SQL injection patterns. So that's what we mean by cross-cutting concern. Security should be built within the code base as a whole, not just on the presentation layer. So how would you prevent something like this? There's a programming pattern called the circuit breaker pattern. And typically what it's used for is to handle fault conditions within the application. So similar to like rapid fail detection on IIS. And basically when abnormal conditions will exceed a threshold, you open the circuit breaker and it'll shut the user off. And what this will do is, it's not going to necessarily stop everything, but during that recon phase, it'll give you time to kind of investigate and sort the mess out. So how do you do that? You use an aspect-oriented programming approach. You create an audit log table, log the user's IP address, username, user agent, timestamp, the type of error, any details. The one thing you want to make sure is you don't put the stack trace in there, because the stack trace can leak information about your application. And if there was ever an attack on that database.
Yeah, can I jump on that? Yeah, so I love stack traces. And I love it when it's all logged centrally. And I love it when it's all logged centrally to, I don't know, let's say Splunk, in theory, hypothetically. And I love when Splunk is set up with default creds, or, better, Active Directory integrated, where we can run responder, get the admin creds, log in. Oftentimes when you log into that SIM as the bad guy, now I've got access to a ton of data, right, that I can go through. So definitely be very careful with what's logging. And that's not only internally, that's also whenever you're considering sending it out to a third party, right, managed security services. You're going to ship out all this very sensitive data outbound, right? How often did someone type in a social security number in a wrong field? Now I've logged it. Now I put it in my database. Now I've shipped it out across the network.
Yeah. So, one of the things that you can do is, especially if you're being very specific in those areas of your code, you can give like a code so that you know where in the code it was, but not necessarily leak it out into the log. So it gives you time, it gives you that ability to actually go back and review your code. You log to the table when the abnormal condition occurs. So once you see, a 500 error, any 500 error, any 404, you just log it to the table. These are what the tables look like, and then what I do is you'll have a multiplier. So here's your audit log. This is the severity, and you do a multiplier. And this is basically like, if I detect a SQL injection attack, it's going to move the user closer to that threshold at a quicker rate.
So multiplier is tied to your risk rating, right? So if I see this, I know the risk is X. So I'm going to put in a certain multiplier so that that threat elevates quicker, right? So if you think about circuit breaker, 25 watts, I want to make sure that I break through that 25 watts quicker if I'm seeing a whole bunch of SQL injection.
So the great thing about ASP.NET is there's this awesome function called application error. And what it is basically anytime there's a 500 error, this method is called in the application. And what you do is you basically get the last exception, log it, create your audit log, and then store it back to your database. And there's an application begin request. So when the application receives a request from the user, it would check to see if the circuit breaker was open. The algorithm is actually really simple. You basically just get the threshold, get from your database the total. So you sum up the multiplier. So you get the total number of abnormal conditions that occurred, and you check if they've surpassed the threshold. It's a really simple algorithm. And then if this is true, basically you just send them off to the error page. So at this point, what we've done is we've kind of put in some detection points within our applications to look for they're abnormal conditions that you just don't know exactly what they are.
Yeah, so it basically comes down to time-based security, right? We want to slow down the big bad wolf long enough so the pigs have a chance to detect it and hopefully respond. Or want to slow me down long enough that I go on and find another pig. All right, time-based security here. All right, what is next? So from some recon, assuming that you don't get those things in just quick enough, I can get some cool details. I know that maybe you're running ASP.NET. It's an IIS site. We got some SQL going on. And then I can start poking it along with all the normal attack tools, right? I can throw in burp, and I can start looking for SQL injection. I love SQL injection. Actually, I really love SQL injection. My daughter, I'm so proud of her. She's now 15, but she did her first CTF at 10. Is anyone here playing the CTFs? Getting a hack on some stuff? Oh, come on, play the CTFs. Yes, thank you. She did her first CTF at 10, and she won a whole bunch of points at doing a SQL injection attack, right? Like, yeah, that's my kid. And she goes to the next day, she goes, you know, I'm kind of sad. I wanted to get a bracelet to celebrate winning. I'm like, that's awesome. She goes, yeah, and I kept going to all these sites and typing it in so I could order it, and the site crashed. What's a 500? Well, honey, thank you for pen testing. SQL injections everywhere, right? So the default SQL injection on an admin page works 9 times out of 10. And you mentioned you actually had that was like one of the first things that you got into.
What got me into it, and actually it was this exact problem. Somebody was able to get in through our login system using a very simple SQL injection like this.
So I've done some recon as the big bad wolf. I found my little pig. I've now done SQL injection on his website, and to add insult to injury, I post bacon.
All right, so you know, at this point, obviously there's bacon on the website, so the pig knows that there's something wrong. You change your password, no avail. Bacon keeps coming back. Now, I have to remind everyone that developers are not incident responders. They're not people who will, you know, kind of be able to do forensics or investigations at the same level as everyone else. But all developers should be familiar with how their logs work. Not only the ones that they keep, but also like IIS server logs and things like that. So a developer should be able to check the server logs for activity around the time of the attack and notice that the IP address is logged into the administrative section. One of the problems with like IIS, for example, is you can't see post data just because it doesn't log it. You can see some get data, but you can't see post data. So that's a problem. So what should a dev do at this point? Well, they should pull out the threat model. If they've done the threat model, they should pull it out. That should be a living document that they work with all the time. And they should check the application to ensure that they're handling everything within the threat model. They should look for ways that their application may fail. And they should specifically focus in on entry points. So login pages, for example, are an entry point. SQL injection itself is interesting because a lot of people think that the solution is parameterized queries. And it's not the solution. All injection attacks are related to the manipulation of strings. So parameterized queries are technically the right answer, but practically they're not, because what developers will do is they'll create queries that are themselves SQL injectable based on user input, which is not good. So the real solution is to use an ORM, an object relational mapper. And what that does is it creates an object map that the developers can use to query the database rather than creating a query themselves. And it's actually good because developers will actually find it easier to use than querying using a SQL stream. And developers really have to try to fuck it up. I mean, it's not an easy thing to do. There are ways to screw it up. First, you can still pass strings into the ORM. Almost all ORMs do this, but it rarely ever happens, and most developers don't know how to do this.
Can I get the next slide? The next slide is the picture off Google, right? I'm going to just hold on for 1 second. So we're practicing in the coffee shop. I was at GrrCON yesterday, and I was presenting on security culture and a whole bunch of different things. But one of the things I presented on was on SDLC. So I went to Google Images, as one would. I clicked on reuse, as one would, to follow the licensing because I'm an upstanding wolf. And I Googled software development, big pictures, and first row, like 3 over, I'm like, oh my God, that's got SQL injection. I'm using that one. That's great. Let's use that. So I was telling him, he's like, oh, well, the solution to SQL injection, right, is ORM. And you can almost never fuck up ORM. Yeah, I bet you could. He goes, you can't. And I told him the story about, it's everywhere. You Google it. And he goes, yeah, well, I haven't really Googled it. So he types it in, Googles it, and there's ORM with SQL injection. I think that was on the 3rd row.
Yeah, it was on the 3rd row, the last picture over. It's this is called HQL, which stands for Hibernate Query Language. But as you can see, they're actually creating the query based on user input. So it's likely in a situation like this that you will still have ORM injection. That's the new thing now. But yeah, it is possible. It's just you're not supposed to do it this way. You're supposed to do it this way. What you do is, it's really easy in .NET. You basically just drag and drop your table onto this designer, and then you use a link, language integrated query. But as you can see, I didn't manipulate any strings here. I just queried some objects. The last thing I'll say is that you got to be aware of micro ORMs. These are like new and kind of coming into the development arena. They're basically ORMs, but you pass it a SQL query, and it will map to your objects. So as you can tell, you basically are kind of enabling the same kind of behaviors as you had with parameterized queries. Now those are, again, it's harder, but because they kind of recommend that you do parameterization and all that, but it's not impossible to actually leave your application open to SQL injection.
So now the little pig is trying to figure out how I've got SQL injection as a login form. He goes ahead and he finds it and he fixes it. Which again, as a pen tester, is one of my favorite things. Hello, client. I found these 3 things. Client goes, great. I will fix these 3 things. I say, fantastic. I'll be back in 6 months. 6 months goes by. I say, hey, I found 3 things. We fixed the 3 things. No, these are 3 new things. Right? Because every time you give someone a list of patches and they apply just those patches but don't keep up on patches, the problems reoccur. Every time we say, hey, this login page is bad, and the developers go, ha, I will fix the login page and satisfy the security gods. We get in again. I liked your point about whenever there's a vulnerability found, it is a triggering event for a full code review. Right? Whenever there's a vulnerability found, it's a triggering event to look at the overall system. And whenever we have vulnerabilities, we should still go through the exercise to say, what is the underlying conditions in our security program that allow these vulnerabilities to exist? So we don't fix those underlying conditions. It's just a matter of the next test finding the next page that's vulnerable.
Yeah, absolutely. And one of the we made this point earlier is that everybody needs to forget about SDLC. There is no life cycle. It's just a process. Because software never dies, and a lot of times you're dealing with these old legacy systems. So the development teams need to be able to go back to even old systems, review code, make changes, and ensure that they're following security practices.
Perfect. So now, as we're doing SQL injection, we're still poking around. The login form no longer works. but we're creating errors, right? And whenever there's errors, that gives us an opportunity to get some insight, especially if there's, SQL 500 or HTTP 500 or other pages that are giving us some valuable data back. I had someone argue with me that, that's security through obscurity if you disable those. I'll take security through obscurity if it beats the bad guys. Because you'd be amazed at the stuff you can get out of HTTP 500 error. This tweet came out, and I love this tweet. This guy's like, hey, this is why you don't print your stack traces. It might contain your creds. This is a real-world 500 from MD5 Cracker. I wonder what that page does. Second line down, there are the credentials to connect to the SQL database. That is phenomenal. The big bad wolf is happy. So we're going to poke at these 500s, and we're going to get a sense of how the code works. We're going to poke at these 500s, and we're going to get some errors back in the page. We're going to get a sense of the structure of the database. That, combined with Cool and some other tools I mentioned that allow us to understand what the business logic is of this application, will give us enough intel to create a mental model of what it looks like. So when we're doing SQL injection, it's not blind, right? We can be very targeted. Using that, we'll map the database, and we'll dump the user tables through some hashes. This is another one I love when I talk to developers. Developer goes, my passwords are safe. They're hashed. And yeah, oh, I'm sorry, they're encrypted, right? They're encrypted with MD5. No, they're encrypted. That's fantastic. Look, no one can even figure out what this is. Show off. A lot of times, obviously, if you're in the biz, you can take a look at something and very quickly go, oh, that's a SHA-1 hash. Even if you're not, it's a 2-second thing to run something against hash ID, right? And it tells you, oh, this is SHA-1. It's probably in a SQL database. So I dump, as the big bad wolf, that hash from the creds. I run through hash ID because I don't recognize it. And then I say, hey, tell me what the password is. Crack station, 2 seconds. I've got the password. So now I don't have to use SQL injection on the login form. I use SQL injection to dump the users. I can log in, and I can post the bacon.
Now the pig is like, what the fuck is going on? I just fixed this problem, and I got bacon on my site again. So again, the first thing that should happen is you should review your audit logs. If you review your audit logs, if you're logging, user logins, for example, you should be able to see that. You should be able to see a pattern that the administrative user logged in normally. And again, you should review the server logs. If you review the server logs in a case of, a lot of times it's, when you have a GET request, it says like ID equals 1 or something like that. And those are a lot of times used for SQL injection to actually dump tables and things like that out. You should be able to see those in the logs. So if you do, then you can, again, go back to what we talked about earlier, which is just use ND framework or another ORM to on the front end to stop the attack. The other thing is...
Can I stop you? Sorry. One other thing I want to say about this, right? So these threat models, we've talked about threat models being a living document. Every time there's a new attack, updating the threat model, either it's an attack on our own organizations or an attack on others that we're investigating or have read about. So these threat models become our way of understanding the world, our way of understanding how the criminals are moving through the network and through the application. This drives logging. This drives a lot of our activities. I used to talk about Schrodinger's log, right? So if I'm doing forensics, I don't know till I get in. Am I going to have way too many logs I can't use or no logs? And it never seems to be in between. It's the developers like, I heard logging is good, so I'm logging every single GET request. Can you tell me where the bad guys got in? No. Or the other one, I heard, logging is really a waste of time, but I did log when the application started, and I think they stopped it when they're attacking us. This is my favorite way to make new incident response guys cry, by the way. So, look, we need logs that are somewhere in the middle, somewhere in that sweet spot. And the way we get logs in the sweet spot is by tying them to the threat model. Here's how we think the criminals will move to the network. Here's how see, you guys are bad. There's only 2, and both of them are way off. Excuse me, GrrCON organizers, can I get better trolls? So when we're doing this threat model, putting that log entries in the right spots and not logging everything and not logging too little.
Absolutely, and that also goes to the training that developers need to have to know what to log. A lot of times developers have no idea what they should be logging. Typically they'll log like there was an exception here, and that's pretty much it. They have no idea what's going on. So anyway, the other thing that needs to be in place is a good incident response plan. Again, a lot of organizations don't have or don't involve the developers in incident response and the incident response plan. So they should have that beforehand. Make sure to practice it because basically if you don't practice and you don't execute the incident response plan, when the real thing happens, you're likely to make mistakes. So make sure to practice, and then finally just execute the incident response plan when something happens. So what do we know? We know that the user database was dumped because the log told us that there was a kind of a union or something on the user table. So what you want to do is regenerate all the passwords. You want to use something very secure. So in .NET, there's this thing called the RNG Crypto Service Provider, which is a secure random number generator. Have a good security policy. So 10-character minimum. Make minimum password complexity requirements. Email all the users and execute the password reset function.
Wait, email the users the password in clear text? Just checking. I wanted to make sure.
Email the users a kind of a reset link, so send them a token, and make sure that that token actually expires so that if somebody did get their email, they can't go and reset the password. Don't use links, and then make sure it looks professional, that it doesn't look like a phishing attack.
Not that would ever happen. GitHub. You guys may have seen this. 40,000 user accounts were compromised in GitHub. This was about a year ago. I spend way too much time on Twitter. These two stories will intersect, I promise. 40,000 people lose their passwords. GitHub decides, we're going to do something about it. We're going to do instant response. Good job, GitHub. They didn't really have a plan, so they put together a war room. Okay, I buy that. GitHub then amused the rest of us on Twitter by emailing all these people, and it looked just like a phishing attack. At like 10 o'clock or in the morning, I'm seeing people go, hey, I got phished by GitHub. 10:02. Hey, did anyone see this GitHub phish? 10:10. This has got to be not legit, folks. They emailed me a new password in clear text. The big bad wolf likes GitHub. Oh, yeah. I mean, so that's where like everyone puts their code, right? I love GitHub. GitHub is also fun for Google dorking, right? Show me your passwords. There it is on GitHub.
All right. So the other thing is with the passwords, he cracked it. He showed a SHA-1 hash, which can be easily retrieved through a rainbow table. So what you want to do is you want to salt the passwords. You want to use a random salt for every single user, and not like one random salt for all users. That does happen. There are very special cases where you would do that. An example would be some low-level PII data that you want to be able to search. You would use one salt, but it's not. You wouldn't ever use it on anything that's very high PII or anything like that. So you store the salt in the same field as the password, or kind of another field in the same row or something like that, and you can leave it unencrypted. It's not a problem to leave it unencrypted. What this does is the cryptographic hash functions that are used for password security. They have a property called the avalanche effect. One bit change will cause 50% of the bits afterwards to also change. And when you add a salt to the beginning of a password before hashing it, it causes the hash to be considerably different than it was before. However, the functions that are used also matter too. And I say that because, with SHA-1, for example, I did a test and I could do like 360 megabytes per second. And they're made for very fast, for hashing files. So what you want to do is you want to use a very slow algorithm, something like bcrypt or scrypt or PBKDF2. I prefer bcrypt just because it's so old. Old is usually better in cryptography.
Oh, can we pause? Old is better in cryptography. So, crypto, wine, hackers, all get better with age. Go ahead. Just want to put that out there.
You use PBKDF2 when there's a situation like you have to use some sort of this standard, and PBKDF2 is used for key derivation. It is in this standard. bcrypt and scrypt I don't believe are. You install a bcrypt NuGet package, and then you increase the work factor as computers get faster. What this does is it makes it very hard to generate a rainbow table based on a particular account or a particular salt.
So hard because we got different salts for each one. So you can't just create a rainbow table based on one salt. Hard because we got a work factor of a older crypto algorithm that will run longer. So again, it's time-based security, right? We're just trying to slow down the wolf as much as possible.
Right, and also notice that, or I should also mention that this doesn't affect the user at all because it's slower, but to the user they don't really see anything. It's in milliseconds.
All right, so forget SQL injection. Tired of it anyways. As you log in, right, a lot of times the way we pass session state around is by cookies. We all know that. I'm sure most of you guys saw Firesheep, which was phenomenal, which was the attack that will go out, look for traffic, sniff the wire for people logging to Facebook, grab their cookies, and you could log in and impersonate them, which actually wasn't that fun. Who wants to be someone else on Facebook? They'll start messaging you. All right, but so cookies, right? Our roles are in cookies. Our password or our IDs are in cookies. Lots of things are in cookies that, when you get at them, can be modified. You can throw it through OWASP app as a proxy, modify on the fly that way, modify the response back. Firesheep was named after Firebug, which is one of my favorite ways to do it. You just throw it into Firefox and modify it on the fly. So playing with cookies, the big bad wolf can change his ID to a admin ID, get in, and still post bacon. You're up.
All right. So things like cookie manipulation are really difficult for developers to kind of investigate after the fact. And the main reason is you're not logging cookie data. You're not like logging every cookie that's submitted to your website. But developers need to know that cookies are just user-submitted data like anything else. So what you want to do to investigate something like this is you look for admin actions not done by an admin user, right? So if they're logging admin actions, then they should recognize that there was a wolf that was posting bacon to the site. So this, again, should initiate a code review. One of the thing that you want to do is encrypt your cookies. But crypto is not enough. You have to use the correct algorithm. So your developers need to work with the security team to understand what's the right algorithm to use for the company, what's the right mode to use the algorithm in, how do you generate your keys, where do you store your keys. Those are all things that security professionals should be talking with the developers about and should be standardized. You don't want to use ECB mode, for example. ECB mode stands for electronic code book. That leaks a lot of information about the cookie. You want to use something like GCM mode. GCM mode provides security and integrity. So if the cookie was tampered with, you'd be able to detect that. GCM is not in the .NET framework. So in some frameworks you won't have it. And it does exist in a library called Bouncy Castle, which is available for both Java and .NET. But if there's a problem with installing that library at the company and you have to use CPC mode, use CPC mode with an HMAC. So do an HMAC over the entire cookie and then store them together. And when you receive it back, first check if there was any tampering. HMAC stands for hash-based MAC. So basically, what that is you're going to have two keys, one your encryption key and one for your HMAC, and the HMAC will provide a signature over the cookie. Okay, so what things do you keep in the cookie? Username, roles, IP address, and you should be checking the IP address before authorizing the user to perform an action. The only problem is sometimes legitimate uses of proxies are problematic for IPs. So if the user logged in with one IP, but then he's accessing pages with another IP, they could be problematic. And any other identifying data you want to keep in your cookie, and you just want to keep it encrypted. And if you do have it encrypted, then the wolf won't be able to manipulate the cookie to get into the edge.
So the username part is fun. Because when we're talking about EBC, this gets to like known plain text attacks, right? So the Enigma machine, right? You guys see that movie? It was a great movie. How they defeat the Enigma machine, they knew the first lines that were going to be said, and they were able to reverse it. It's the same basic concept with some of these weaker implementations, which is interesting because that's like the default with .NET, but it is what it is. So if you got that known plain text, you have the ability to kind of start reversing it out. It's a lot of effort, though, so a lot of times people won't spend that effort, but it is there. So I like that HMAC version. So even if they can reverse it out, they can't modify it using Firebug or a proxy. So I'm up for a different attack then. Redirects. So all right, so I'm poking around the site. I'm changing my cookies. He's now fixed it, and he's implemented the circuit breaker pattern, which if it happens too often, in this particular way of doing a circuit breaker, if the cookie changes like 1 or 2 times, right, you're not going to change very often, almost immediately. Right, so it'll immediately redirect me to the login page. So as the wolf is poking around, I notice that no longer works, so I can't change my cookie. I get redirected to the login page. I look at the URL of the login page, littlepig.com/loginasp ? Back to the page I was on. That's nice. That's very handy. I like that. I can take that redirect page now, right? It's just like with Google, right? You take Google and you click on Google and it's got the link. And, I could do a phishing attack. Or I could inject something in the login page. I could take that login page and redirect it to my own login page so that they log in twice. Or they log in and sends it back to a site to me. Lots of fun there. Oh, and that was one of the things I was thinking about, right? When you were 14, you were writing pre-calc. You were such a good kid. DOS, right? Autoexec.bat. Now I'm really aging myself. But like I was saying, like crypto, hackers. Never mind. DOS, autoexec.bat, Windows 3.1.1, Network 3.1.2. Here's how the logins used to work. The computer would boot, autoexec would run, it would call login.exe. Login.exe was a DOS-based app that would log into network, capture your credits. Nice red screen, welcome to NetWare. Low prompt, passwords. Know what I was coding at 14?
Something without autoexec.bat, I'm guessing.
I had a Wolf exe, right? That one time in 10, it would look just like that login form, capture the credits, say, oh, I'm sorry, you have an incorrect password, and then send them on to the regular one. Great way to catch passwords. In a controlled, safe environment, of course. But that's the exact same thing. With these redirect pages, we can do that attack that we were doing, early 90s on the web and more. And that allows us to do prompts for login. We can do cross-site request forgery, so we can steal information that way. All sorts of good attacks, which is important because there's more than one pig, right? If I've got a website and I know it's got these vulnerabilities, I only need to get one pig to get in. I only need to get one access point. The Verizon breach report, I loved it. If you send 10 phishing emails to 10 people in an organization, you have a 90% chance of getting in and breaching. I only need one pig. So we'll send an email that looks like it's coming from his brother, from my friend Mo. Hey, please register. Here, click to log in. And thanks for the password to the database. Simple as that.
So the pig will receive an email, click on the link. It looks completely legitimate. He looks successful at first, but then he's redirected to the page that the attacker is controlling. To him, it just looked like something didn't take. And so he re-enters the username and password, and we got bacon.
Yeah.
So social engineering is one of these is one of these really difficult kind of attacks, and the reason is there is no technological solution. The only way that you can really fix social engineering attacks is to train the people who are using your applications. And at this point, I mean, the pig basically, he screwed himself. So, how do you fix open redirects? So, open redirects are actually one of the simplest things to fix. First, you verify that the redirect is on the same domain that you're on. You verify that the redirect is a relative URL, or you check the redirect against the whitelist if you do allow it to go to other domains, or you use magic. And what I mean by use magic is .NET Framework has this awesome thing that checks if it's a local URL. Developers don't even have to do anything. Basically, when they're about to do a redirect, they just send it to this function, check it. If it's legit, redirect to it. Otherwise, take them to the home page.
And that's it, huh? So we covered SQL injection, we covered cross-site scripting, we covered open redirects, we covered reconnaissance, circuit breaker pattern, aspect-oriented programming, type squatting DLs. We didn't talk too much about that, but extra Y, right, in Nerdy Wall. So we covered that. We covered a lot of stuff today as we're breaking into these pigs. And again, the important thing here is Dirtbuster, only one guy is looking for it, right? A lot of us are not doing these basic things, which is why the attackers don't have to do any of the complex things, right? We only have to move from, I don't know, at this point, the straw to the woodhouse to have a good chance of thwarting a lot of these companies. They don't care. They're not after you. They're not after me. They're after whoever they can get next and whoever they can get easy. And if we can just get rid of that low-level noise, we're in a much better spot. And so a lot of these things that we're talking about allow us to do that.
And you really have to think about, well, what are the pillars of a secure development team? They are basically security training, ensuring that your developers have a good security training program. Identifying abnormal conditions. This is not, I mean, it can be done with training, but it's something that you have to kind of teach a developer to look for certain conditions that don't seem obvious. Incident management and assessing and practicing. So these are, to me, the four fundamental things in having a security development team. What you have to remember is that there is a difference in thinking between developers and security professionals. As a developer, I take business requirements and I turn them into cool stuff. I think about abstractions, mainly because I'm lazy. I don't like to write too much code. And think about the titles in software development. Developer, craftsman, architect. It's all around and focused around building things. Whereas
the cool stuff is how it breaks down, right? So developers are thinking about abstractions, but 9 times out of 10, if you think about the last really cool hack you saw, right, that you read about, maybe you see it here at GrrCON, it's usually something that we thought the abstraction was this, but the implementation was really that. You going to do that to me again?
Sorry, just keep going.
Wow, a little passive-aggressive now. No, just kidding. So it's usually that delta, right, between implementation and abstraction that we fall into. It's that delta that the bad guys are going after. There's a really cool PHP hack. I loved it. There's no amount of training you could give a developer for. Why? Because PHP, they think as a PHP, was really a C null character attack that PHP just happened to pass down the stack, right? Because PHP is built on C. So it's those types of implementation details that fundamentally allow the weakness, right? That's interesting. It's the borders, it's the edge cases, it's the errors and the unknown that attract us to being hackers, that attract us to breaking things, and that are fun. And it's really a night and day difference between that and developing.
So what we need is a new type of developer. This is a developer that I have never seen that actually exists. If you think back at architect and craftsman and developer, we really need the civil engineer. They're the people who make sure that the structure is safe. They're the ones that know the ordinances. They know the rules. They make sure that the developers and the development team follow the building code. And they know how to make the building fall gracefully if it does have to fall. And this is, to me, it's really it's a type of developer that I've never seen, but I think that if we want to make secure software, we're going to need to see more of this.
And when did QA developers become a thing? 10 years ago? So like 15 years ago, there was probably someone going, we really need to do something about that quality thing. Good. So this concept of having a dedicated developer, we've already went down that path with QA, right? This concept of having a developer who is responsible for security, we've got a model to follow. Let's find those stakeholders, the people who are really charged up about it, and let's embrace them and give them the tools to do that so they can become those building inspectors and look for the common things that the pen testers are going to go after, that the criminals are going after right now. So how would this work in a development lifecycle? This is more my baby. I love looking at security programs and development life cycles and figuring out where the security comes into play. So this is just a very standard OWASP style SDLC. Everything from requirements, where you're building those threat models, you're doing the architectural review, you're doing the walkthrough and making sure that it's secure. Development, where you're doing static analysis, you're running that code and looking for the common patterns, right, for weaknesses, code level vulnerabilities, and feeding those back to the developers. As they're building it, they're fixing it. When it moves into verification, then you're doing static on an ongoing basis, part of QA. And dynamic analysis, you're looking at the website as it's run, you're going through, you're fuzzing it, you're doing SQL map, WP scan, those type of activities against that site, leveraging the QA processes and looking for the vulns, hopefully remediating it, doing app pen testing. One of the things, a couple slides back, that we kind of glossed over, and I hate to say this, but pen testing is not a security strategy. You're right? Our pen testing is phenomenal. It's great. It's fun. It's a key component. But if the idea is pen tester, go find 3 things wrong, I will fix 3 things, that means we're on a treadmill, right? We've got to get into a program level perspective. So we bring the pen testers in, we have them do the manual testing, beat the hell out of it, and then we deploy it. And once it's deployed, we protect it with application firewall. We protect it with monitoring. We put in place the rules to look for these errors, the circuit breaker patterns, and we continue doing dynamic testing. Because, what was it, ORM injection? ORM injection didn't exist, 2 years ago. It does now. Right now, there's new attacks being developed. These attacks find their way into dynamic tests. Those tests run against our code. They'll find weaknesses that all this missed because someone just invented it at Hacker Summer Camp, right? Dynamic analysis ongoing allows us to take the best of the best and continually assess our program. Where would your guy fit in all this?
Actually, I would say that that particular person would fit at all levels here. They should be involved in every single level because they need to know when there's new attacks, for example, on code that's deployed. They need to be part of the architectural review. They need to work with both the security and the development team in ensuring that the developers are learning these new techniques and know what's happening. So I would say all levels.
So he'd be involved with checking the architecture to make sure it's right.
And then the threat modeling. See, threat modeling is one of those interesting things because threat models are great, but they're only as good as what the information that you get back when you're doing a threat model. So if the developers have no idea what an open redirect is, they're not going to tell you that there's a potential for an open redirect. They have no idea. So, it's one of those things. I would say, yeah, it would be involved in architectural review and the threat model.
And how about in development? When you're talking about the algorithms to use for crypto, that's not something that's going to be common knowledge of most developers either.
I would say crypto algorithms, base architectural frameworks that you build, AOP frameworks, the logging mechanisms, and how you should be logging, those should all be done by that type of developer. It shouldn't be every single developer. And, frankly, developers today are working way too much, and they're highly likely to make a mistake. On average in our field, it's like 50-hour a week, So Yeah, I would say that they would build the base frameworks that the developers would work off of.
And then you touched on aspect-oriented programming in this talk, right? So aspect-oriented programming has a set of rules that need to be maintained.
They do, and so what I would do for aspect-oriented programming is you would have the security developer be building the code for that, and then the other developers implement it, actually put it into place.
Right. So he's basically in an audit and oversight function. Perfect. And then interacting with the pen testers, helping make sense of the issues they find.
Yeah, so having an understanding of security and software security, that particular type of developer would know how to work with a pen tester, whereas a normal developer probably would have no idea.
And then finally, when life cycle runs to life support, when they're in the monitoring, every single time there's a breach or something, getting them back engaged to review the threat mouse, to update it, to do another code review, to make sure that they're capturing that knowledge of that attack and fixing across the board. Sweet. So that's what we've got. Any questions? Yeah, sir.
So you're in the verification stage. What if you're dealing with a third-party application? So you weren't at all in the process. You don't know what if they're using SaaS or anything.
Yep.
How do you hold that party accountable?
When you're in the verification phase and you're doing testing, how do you hold a third party accountable? You hold them accountable 6 steps ahead of that. In the contract phase, where you have a contract language that says, thou shalt produce quality code. Quality code is defined by minimal amount of defects. Our defect testing process looks like X. So it starts with vendor risk management. Yeah, sir, in the back.
Back to SQL injection. A lot of times, it's not unusual for the .NET developers, database developers, and servers. So a .NET developer who's been using .NET for 10 years, using the video.NET, and he's hey, call a store procedure, here's your list of parameters. Going down to the SQL side, they still might be using that SQL on all the parameters that you pass. You know, it's var, SQL equals select star from blah, and later down it's execute SQL. So you also run into that scenario way to protect against that. How does your database developers bind variables for how dynamic SQL and regular store procedures and all that actually work underneath the hood? With bind variables, all of that dynamic stuff can still be done, but they're viewed as parameters. Not in SQL scripts.
Perfect. So the sum of that, I'm going to sum it up real quick, and then I'm going to cut it. 2 things: engage the database admins and developers along with the programmers. 1. And second thing is realize that not only when your pen test is the fault between abstraction and implementation, it's also the fault between person A's understanding and person silo B's understanding, right? Because what the database guy thinks and what the programmer thinks, the difference between those is where a lot of vulnerabilities will lie. All right, thanks a lot. Our contact information is up here. Enjoy the rest of the conference. No one got me, really?